it going? So, remember this here thing? The Permobil Volt Pro charger, aka the Invacare OptiCharge charger? Well, I've done a lot of looking around, and I have not been able to get any details about the charging curves, or the algorithm, if you will, that they use when they're charging their 10 amp new technology batteries or whatever. So, I've come up with a solution. Today, we are going to build a data logger. Now, this is going to take some time once I get it set up. The idea is we're going to build a data logger, we're going to plug the charger into that, and then plug that into the chair. And I'm going a little bit old school on this. Let me show you what I got here. So we've got another one of these D-Rock style Hall effect current shunt monitor things. Anyways, you pass a wire through here and it'll tell you how much amperage is going through it, DC, in or out. And this little display will count up all the information and add and subtract and all that. This doesn't data log on its own, but my thought is we're going to point a camera at it. But before we get to all that, I need to build it, so that's what we're going to do. Now, I didn't go out and buy the actual Nutric XLR ports. So this is a, what is this? A Nutric NC-MX. This is basically a 16 amp capable 3-pin XLR. They're like $18 each or something. So what I did instead was just looked around on Amazon and found the highest ratings for good quality XLRs. And what we ended up with here are just some of these generic-y, come out of the box. Some of these generic-y things, and everyone says that they work well. I don't know if that's for audio or whatnot. They do have a latching thing on them, and I did get the male and female version, so we can plug the charger in and then pass it through. So I'm gonna get everything set up here. I'm just gonna film with my lap desk because it's raining and there's mud, and I don't really feel like getting my chair even more muddy than it already is, to get the folding table out of the luggage bay that's on that side of the bus. So anyways, let me get some stuff set up here. I've got a very crude, gun style soldering iron we're gonna use, which I think should be okay. Let's look at these real quick. Yeah, actually these look like some pretty good solder on connectors that go inside these things. So anyways, I'm gonna get all that set up and then we're gonna start to putting this thing, start to putting it together. Something, and of course a fuse. Okay, this is not the best filming setup ever. Actually, I think we can move this a little closer. There we go. This is what I have to work with right now though. So what we need to do, well actually, let's start with our XLR connectors here. And yes, by the way, there's a blue piece of tape on my thumbnail. Getting kind of tired of comments about how my nails are messed up because I eat McDonald's or drink coffee there or something like that. I dropped a milling machine on this thumb a few years ago, and it takes a while for things to heal. So anyways, what we're gonna start off here with is, put those over there, wire. I don't have red and black. I don't know where it all went. So we're gonna go with, how about, we'll go with white and yellow since apparently they're hopelessly slinkied together. There we go. And this is the female one, which means that positive is going to be pin 1. So, I think we'll do yellow for that. Cut off a random length of wire there. Yeah, that fits in there nicely. Oh. Now I've selected the most appropriate soldering tool for this. This is what I just happen to have. And if you're sneaky, you can do it without melting everything. Actually, I need to rotate this a little bit. Trick is, you gotta be pretty fast. Actually, I'm gonna tin this first. You have to be pretty fast soldering up these connectors because the plastic in these connectors will melt fairly quickly. So you gotta be on your game. I think that is good. Yeah, that should do nicely. Okay, I'm gonna go around and solder up the rest of these connectors and then I'll be right back after that. All right, we've got these two wired up here and our pins seem to have survived the soldering process. You know, these look like Nutric clones, but they are very good, I must admit. I don't know. I mean, we'll see what happens when we start passing 10 amps through these. Obviously, over the long term, this is probably not something you want to use because I have no idea what the rating is on these. I couldn't find it anywhere. But for the little bit here and there we're going to be using them, I think we should be fine. Okay, I think the plan here is we're going to power this from the wheelchair side. Obviously, when the charger is connected, well, I mean, battery power is going to be coming from the charger and the batteries on the chair. But I want to attach it to the side that the chair is on so that we can unhook the charger and this thing won't reset. I believe this thing stores the data when it's not powered up, although I don't remember. I used one of these on the Bounder, but I remember now that it is always connected to the batteries. So anyways, let's pull this cable off of here just for convenience. And then I believe this is going to be our power right here. There we go, that seems good. What I probably should be doing is mounting this to something like a piece of wood or, I don't know. This thing's designed to be powered off of whatever battery system it's connected to. It's got a bunch of relay outputs and other things that we're not going to be using for like circuit protection and whatnot, but yeah, not too worried about that. Does this thing have a fuse on it? I don't think it does. I guess we'll put one in line. I know I mentioned it earlier already, but never a bad idea to have fuse protection when stuff's plugged into your chair. Okay, and I'm paying fairly close attention to how I'm doing these connections, seeing as how we're going to have, you know, a decent amount of voltage and amperage going through the wires. The 10 amp mode, or 10 amp charge mode, I found doesn't usually last more than about a half hour on typical chargers, but regardless, I'm doing the thing where you mash the wires together lengthwise and then tie them up that way. And what we're going to do is use our fuse block to run through our Hall effect sensor here. See, this is battery side. I think that's supposed to point towards the battery, although it doesn't matter because it's bidirectional. So let's just, how do we want to do this? These wires are very long. I'm gonna get this figured out, then I'll be back and show you what I've done. Okay, fast forward a little bit. This is turning out to be far more jank than I was planning on. Given that I'm in the bus and I don't have all of my tools and project boxes and everything, this is what we get. It'll still be functional, however. Let me get a fuse here. Let's do a secret amperage of blue. I think we are ready to power this up and see if it all works. At least plug it into my chair and see if we can let the magic smoke out of anything. Preferably not, but hey, you never know. Okay, that's all connected. Kind of point that over there. Got most of the wires tied up so that things shouldn't short out. Let's go ahead and bring the joystick in frame here and see what happens. Hey, it lights up. Cool, so we currently have 25.7 volts. I have been running around with this chair a bit today. I don't think I've gone more than 1.5 miles necessarily, but we're gonna have to, I was gonna say we need to program in the capacity here, but I don't think that really matters. Let me hook up the charger and we'll plug it in. Let me hook up the charger and we'll plug it into this. And in theory, we should see the amperage go up on this thing. Oh man, this is one of those projects that I started with an idea and I'm like, I want to get this filmed and published today. It's not super complicated, but at the same time, I don't quite know what I'm doing as far as planning it all out. Anyways, this is coming from our Volt Pro charger. So let me jam this down here next to my leg so it doesn't try and escape. I'm gonna plug this back into my chair. Gonna put that down there out of the way. Now I have not actually looked at the Volt Pro charger at all when it comes to the amount of voltage and stuff that it outputs. My chair needs to be a little bit more dead for this to work properly. So just for now, let's zoom in on this thing. There we go, I think you can see that. Here. Okay, I've taped it to a roll of tape. Do I need to check and make sure our voltage is correct? Nah, YOLO, let's just plug it in. Okay, so we're gonna plug this in, and in theory what should happen is, well, that won't turn off. Turn back on. In theory, what... Come on. Okay, in theory what will happen is this voltage will go up, and also our amperage will go up. That or something will go bang.
I found this on the web for what will happen if there's moldy Gujarat. Check it out.
My phone keeps thinking I'm talking to it. Okay, let's hope the angry pixies stay where they're supposed to. Okay, heard the charger click. We've got 8, 9, 10.1 amps flowing through this thing right now. And currently at 28.41 volts. Now I'm actually kind of curious here. I'm just going to leave the camera zoomed in on this for a minute. I haven't used my chair enough today that, well, what I'm trying to say is I don't think the bulk charging mode is going to last very long. So I'm going to keep the camera running here, and we're going to keep an eye on that for when the amperage starts dropping. I think it might happen within 5 minutes. So, okay, we're at 29. And if nothing else, that'll give us the voltage that this thing clicks out of bulk charging mode in, which was one of the things I really wanted to know. 29.3. I'm going to guess that it's about 29.8 volts. Maybe 29.6. I'm just basing that on the Odyssey Extreme batteries that I'm using, which appear to have similar properties, maybe. Okay, I'm going to shut up, and then let's keep an eye on this. There's also currently only one light on the charger right now. I'm assuming that light will change when it switches modes and the amperage drops down a little bit. Whoa, it's going up above 30 volts? Seriously? At 10 amps? No wonder things were melting. Okay, our second light has come on, and now we've gone down to 9.5. I just happened to look at the charger. I don't know exactly when that happened, but you can see our amperage has dropped. Our voltage is 30.06. We're just going to say 30. I assume it's within the margin of error of this thing. But yeah, that is very interesting. Huh. Yeah, and the second orange light has come on the charger now. Yeah, so this has gone into absorption mode now. 8.8 amps. Still hovering right around 30 volts. Huh. Well, anyways, I'm going to unhook this. Yeah, these batteries are definitely more than... I wonder what the rating of these batteries are. I need to open these up and look. Okay, this is super freaking interesting. 30 volts. Huh. I'm really wondering now what... Well, anyways. I'm going to fire up the hot glue gun and turn this abomination into even more of an abomination. And then I'll show you the final result. The idea is I can plug this into the chair and then set this thing on the seat of a chair and point a camera at it. And put a clock next to it or something like that. And we can run a few charge cycles. I'm gonna see if I can get a hold of some Volt Pro batteries that are not in a chair through some resources. And yeah, because that'd be far easier to run some cycles than trying to do it on my chair. Because some days I don't even run my chair a mile. And I would like to see, you know, batteries that are maybe at least 50, 60% discharge, something like that. Anyways, I'll be back. Is Big Wheelchair trying to hide battery charging data from you? Well, I have a solution. The Super Jank 5000 data logger. This thing is made from the most premium bits of IKEA storage bins, cheap Amazon electronics and knockoff XLR connector wires. This will allow you to data log everything having to do with charging your wheelchair. Why does the 5 look so strange? Nobody knows. So the idea here is we've got our current monitoring shunt here, and as you can see, our wire is passing pretty much through the middle of that, and this plugs into the chair, this plugs into the charger, and then this little screen over here should fire up. Let's see here. Okay, there we go. Wait, is this data persistent? Oh, it is! It's saved. We put in 0.21 watt hours previously. So the idea here is this thing can sit on the seat of the chair where I'm sitting currently, and you can stick a GoPro or something right here and have it look at this screen. Oh, I need to put a clock or something on here. I'll have to find one at Goodwill. But anyways, it's a thing. Now that we have this thing built, I can actually set it up and use it. The problem is right now, like I was saying, I don't necessarily use my chair and run the battery very dead or very low during the day. So it's going to be a little bit harder to get information on a short charging cycle versus one that takes like 8 hours or something. I'm going to see if I can get a hold of a set of those batteries and do this outside the chair. That way I can connect a load like a giant light or a power inverter and, you know, use this gauge to measure how much capacity we've taken out of the batteries and then how much we put back in. At this point, now that this thing's built, and we found out it charges to 30 volts in bulk mode, I'm not quite sure what to do now. So, I'm gonna get some dinner, and in the meanwhile, I have some more clips of things that I've filmed over the last couple of days, so yeah, here you go, more random footage. Future me with slightly more coffee in my system. Just realized I need to set up this footage you're about to see. So, as I was talking about a few videos back, I got that bilge heater thing, aka the freeze prevention heater, because I've got the rear luggage bay in the bus, has the water tanks in it, and also the water heater's going in there. I know you guys haven't seen that yet. Someone did buy me one, thank you for doing that, by the way. But that's gonna be going in there as well. Right now, I've got the freshwater tank about halfway full, and I'm using it to data log and test everything. Anyways, the problem I've been having is it was only supposed to pull 700 watts, but it pulls 1,000. I've said that previously. It started getting colder here, and later this week it's supposed to get down to 13 degrees, and the high is supposed to be 21, and it's gonna snow and stuff. So that thing pulling as much power as it does with everything else that's on in here, like the computer, the pellet stove, and other things, that heater was wreaking havoc on my grid feed because I've only got 1,500 watts of available power. The solution to that, which I also talked about, was getting another power inverter that is dedicated just to run that heater from the batteries. And we'll use the batteries in effect as giant power storing devices. Anyways, it only runs once every hour to 90 minutes and only operates for 3 to 4 minutes at a time. Even though it's pulling 1,000 watts, that's not going to affect the capacity of my batteries too much with the amount of time that it runs. And I have the grid battery charger, which puts 16 amps into the batteries. It'll offset that load. But all that basically means is that thing can run back there, and I don't have to worry about setting up automations and doing fancy things with Home Assistant to keep my breakers from blowing or the overpower protection from tripping. So thank you, by the way, to the person that got the power inverter for me. Finally got it installed, and I didn't pick up the camera until I was almost completely done. So that's the backstory with that and why we're using an inverter. Hopefully that makes sense. But now, over the last couple days, that thing's been running and I can completely ignore it. It's one less thing I have to keep in the back of my mind, and it just keeps the tanks from freezing. And it works perfectly. Okay, here's the footage of that. I just gotten it installed and was about to test it. All right, it's one of those moments of truth. We've gotten the auxiliary inverter installed here. This one is 100% going to be handling the plumbing heater back there in the bilge area. I wound up doing that because that bilge heater pulls 1,000 watts and my entire grid feed here is 1,500 watts. So when that thing's on, it doesn't leave me enough overhead to run everything else in here. So main inverter covers everything else inside. And then we've got this little 1200 VA one here. It's Victron Phoenix 24 volt 1200 VA. We're running 100% resistive load with that heater, so that's good. This thing can surge up to 2400 VA. We've got 4-gauge cable connecting it up here. These 200 amp breakers, I'm anticipating at some point I may trip these, because if, for example, I've got the toaster oven running, which means this thing will be operating, and if that thing kicks on, we might be okay. But regardless, at some point, these 200 amp breakers may need to change. I had to move the ventilation blower back there. You can see it sitting there now, and this is where it goes. I'm probably going to find a different spot to put that. I might put it back over there or something like that. But I'll probably have to get some new tubing to reconnect this back up. This is just our fresh air ventilation. But I think we've reached the point where I'm ready to throw the switches and see what happens. I've wrapped these wires in cloth wiring loom tape. This isn't the prettiest way in the world, but I happen to have these 4-gauge wires in stock, and they run over here and connect in. That uses rising clamp terminals, so 4 gauge is as big as that can go. So let's see what happens. I think this inverter might power up at the same time, so I don't know what kind of arcing we're gonna get here internally on these, but that thing hasn't been powered up. It is low frequency, but I'll just do it. Here we go. Okay. I think I psyched myself up for no reason. Let's turn it on. Okay, we have a green light. Sweet. Cool. I'm going to grab my current clamps. Actually, I need to run another power cord back there to connect to the bilge heater, which is on the other side of that bay. My wiring for that kind of goes down along this side and over and across. So anyways, I think we're wired up. Sweet. I guess we can turn the main inverter back on now. Get stuff powered up inside. Going through its boot up. Okay, I think that's good. All right, sweet. Awesome. It sounds like our bilge heater turned on. Oh yeah, I can actually feel the warm air all the way back here. I probably shouldn't have insulation over that. All right, cool. So that's running off the inverter right now. I never had this hatch open. You can see it right back there. But I've never had this hatch open and felt the airflow. So it's nice, it circulates all the way back. All right, cool. All right, we are on the final stages of getting this bilge heater plumbed into the new inverter we installed back there. Turns out the cord on that thing is extremely long. So it actually starts right inside that hatch, goes up, comes all the way down, back through a hole in the floor, and then goes all the way over there. So I was trying to figure out, I couldn't get the end of the plug through the existing hole in the floor, so I was like, I'm gonna have to drill another hole in the floor. But then I was like, wait a minute, I can just cut the cable in half and then solder the wires back together. So that's what I'm doing right now. Just got these all soldered up, got some nice low profile connections here. Gonna get this taped up, and then we're gonna run the wires over there. And I think it's cold enough back there right now that I should be able to, well, I think the second I plug it in, it's gonna turn on. So they can measure our amp pull through that inverter over there. So I'm gonna finish getting this wired up, and yeah. Glad that this bilge heater came with really high quality cable, but that is how you do a low profile repair. As you can see, it's not any larger than the cable itself. I've got 2 layers around each conductor and then an additional one over the top. I think I'm probably gonna put some of that cloth tape over this, just because electrical tape can kind of catch, especially when it's cold, so that'll give it a little bit more protection. But yeah, I'm pretty pleased with that. Okay, everything's all hooked up. We've got our clamp meter on here, and it is in DC mode. Let's see, get this zeroed out. So all I need to do is turn on this inverter, and in theory, that thing should fire up. Okay, so we had a peak of about 67 amps. Now it's warming up. And we're dropping back down to, looks like it might settle at around 45 and a half. But yeah, it looks like under operation we're at about 45 amps. So yeah, it's not doing too bad. I think this should run that build cheater nicely. And like I said, this thing only stays on for like 3 to 4 minutes at a time. It turns on at 40 degrees and off at 46. And that little compartment back there is not that big, so it heats up pretty quick. And I'm glad I had that open earlier so I could tell that it actually blasts the heat all the way across. So I scratched my arms a bit. But yeah, I'm perfectly happy with that. I'm down here and I've got this bay open. I wound up getting one of these label maker things from Goodwill. It's got USB and stuff, but I need to label a few of these circuits. Because coming down here and immediately trying to remember from like over the last year what exactly all these fuses are gets kind of obnoxious, so I'm just gonna make some little labels real quick. While we're out here and we've got everything opened up, I did get that air compressor mounted down here too. Been having an interesting issue with the lift, or rather the cold weather. So this little bay here is roughly heated by the inverters and battery charging and all that stuff, and a little bit of bleed through heat from the floor. And when it's like 20 degrees out here, this thing comes out and it's whatever the temperature is in there, which is above freezing. Then I lower it down on the ground and all the gravel sticks to it. I've been noticing some weird noises with the lift when I move the thing in and out. And I noticed this the other day. There appears to be gravel down inside the cassette. So while we're out here with everything, I'm gonna use this broom and just kind of sweep some of this out of here. But yeah, the whole thing with gravel and mud and humidity and all that, you know, when this thing pops out and it's above freezing and it's below freezing outside, well, yeah, the gravel sticks. Then when it comes in and hits the end of travel, it bumps, which creates a jolt and makes all the gravel fall off. So yeah, that's a thing. I can't really see down in there. Let's see how far that stuff has gotten in. I think it's mostly just on the front edge of the lift here. There's kind of a support bar. And this is the part that heavily contacts the ground. You can see the marks right there. So I'm assuming all that gravel is on the front side. But anyways, I'm going to get that cleaned out of here. And yeah. So now that we've got that swept out of the cassette, it's down here on the floor, and we can just sweep it outside. Yeah. One of those things that's you don't really run across until you start... What am I trying to say? It's something that doesn't happen until it does? I don't know what I mean. Although where I was parked previously, I had some... giant rubber mats like they use for horse stalls, and I landed the lift on that. Maybe I should get some of those things out here and put one down. I think that would solve my gravel problem. I mean, because it's really obvious right there. But anyways, yeah, things. All right, I'm gonna get the other side closed up, get everything buttoned up, put the tools away, get the pellet stove fired up because it's cold, and yeah, I think we're done roughly. There we go. That's what's been going on the last couple of days. Now, I'm planning, let's see, this is Monday. I'm planning on Wednesday to upload another video. And what we're going to talk about is, let me move my chair here. You know these? Seat elevator? You know, permobil has these new swingaways or whatever that are like thinner than the old ones? Well, I want to investigate this. See how my joystick rattles? That is the connection point right here and down here. And, yeah. I feel like that should be adjustable or something. And also, I haven't taken one of these apart yet. The old ones had chains inside. I don't know what the new ones are like. This one, I think it has a metal cover? I don't really know, though. There's only one adjustment point here on the back for changing the tension of this thing. But the plan is to take that apart and do some investigating. So I used my manual chair today for the first time in like 3 years? I don't think I've used my manual chair for an entire day for like 3 years. Anyways, we went to the mall with our hiking group or whatever, and I just pushed in the manual chair. So I'm kind of tired. I wanted to get some exercise, and I need to make some adjustments to that chair. The back is pretty low on it, and also my function levels have changed since back then. But anyways, it was nice to use that and get some exercise, but that's, well, I'm tired and things. Anyways, I'll see you guys Wednesday with that video on the, it's not the swing away, what does Permobil call it? The retractable joystick mount, I think. Anyways, thanks for watching, and I will see you then. I'm bored.
Unexpected item in bagging area. Remove this item before continuing.